All right, let's take a look at this question here. So we're integrating 2x squared plus 7x minus 3 over x minus 2. Now, the interesting thing here is if I try to do some u sub, right, we're going to have a little bit of an issue. So maybe I want to say u equals x minus 2, but the problem is when I take the derivative of this, I get du equals dx. So that's not going to take me to where I need to be. The issue being that we have an x squared here, right? So maybe we want to say u is 2x squared plus 7x minus 3. So then du becomes 4x plus 7 dx. So can we use that? Well, nah, that's not working out for us either, right? How do we end up getting an x minus 2 in the denominator? We don't. So what do we do? Well, we don't do what I just suggested here. What we want to do is, if I can do some editing here. There we go. What we want to do is actually long division. So what's the tell that we have to do long division is, again, the denominator's exponent is less than the numerator's. So let's do that. Okay. So we can do long division like so. You also can do synthetic division. And since synthetic division tends to be the way that most people are happy doing this, let's do that. So if you recall, synthetic, we bring the 2 down, we multiply the 2 by this 2 by this 2, then we add, and then we multiply, and then we add. So this leaves me with, this is the remainder, this is constant, this is x. This is going to leave me with 2x plus 11 plus the remainder. Now what is the remainder? The remainder is 19 over the divisor, the thing we're dividing by, x minus 2. So what have I really done? Well, I took the original problem and I just rewrote it in a way that might be a little easier to dance with. So why do we like this? Well, because let me zoom in a little bit. Because the sum of the integrations is the integration of the sums, so I can rewrite this as 2x dx plus the integration of 11 dx plus the integration of 19 over x minus 2 dx. What essentially really, the way you want to think about it is, integrating this is straightforward, right? Right? Integrating this is straightforward, right? Integrating this requires a little bit of math, but right, this is pretty much like our first example. Let u equal x minus 2, and then du equals dx. Now that's okay here to get du equals dx, because basically now I'm just left with 19 over u du, right? We're replacing dx with du, right? Replacing x minus 2 with u, and then we're like so. And so that's pretty easy to solve. That's just going to become 19 natural log u plus c. The ones in front are, we'll simplify, we'll get like so. All right, all I did was 2 divided by 2 is 1. Okay. And then again, we're not solving for u, we're solving for x, so we're going to write it as x squared plus 11x plus 19 natural log x minus 2 plus c. What am I stressing here? What I want you to see is that the u value, this is okay, because when I do u substitution, I end up getting du equals dx. So a really good tell that we're going to want to use synthetic division or long division is when the denominator is what? When the denominator is a linear term. Because when you take the derivative of a linear term, you basically just get, you're doing u sub, you're going to basically get du equals dx. And that allows me to break it down. Okay? Now, keep in mind, I'm not saying every time you see it, do it, right? But that is something that is to take note of and to consider. And also, why should we consider it? Okay, hopefully that makes sense, and I'll see you in the next math video.